Hello everyone, in this video I am going to explain these two important formulas of trigonometry. For that purpose I am considering one unit circle in Cartesian plane with an angle x. We can observe it is in anti-clockwise, and from here we are subtending one angle y that is also in anti-clockwise direction. Therefore we can write the coordinate of A as cosx, sinx, and since this total angle is x plus y, therefore coordinate of B can be written as cos x plus y and sin x plus y. Now let us join points P and B. So being one unit circle, the coordinates of point P will become 1, 0. Now by applying distance formula, we can easily determine the length of BP in triangle BOP. So applying distance formula, we can write length BP is equals to square root of 1 minus cos x plus y whole square plus 0 minus sin x plus y whole square. After expanding this, we get BP square is equals to 1 minus cos x plus y whole square plus sin x plus y whole square, because 0 minus sin x plus y will become sin x plus y, and further expanding it in a minus b whole square form, we are getting 1 minus 2ab plus here cos of x plus y whole square. Now we know cos square x or cos square theta plus sin square theta is equal to 1, the basic identities of trigonometry. So therefore, instead of these two terms, we can write 1. Thus, BP square can be rewritten as 1 minus 2 cos of x plus y, and instead of these two, that is in the form of cos square theta plus sin square theta, we are writing 1. So finally, we are getting BP square is equals to 2 minus 2 times cos of x plus y. Now let us come back to the diagram here. Now we are drawing one angle y but in clockwise direction. Therefore, this angle will be minus y, and we are indicating this point as Q. Therefore, coordinate of point Q will become, from the previous concept, cos of minus y, comma sine of minus y, and this cos of minus y that is already known to us, it will become cos of y, and sine of minus y becomes minus sine of y. Therefore, coordinate of Q is cos y, comma minus sine y. So let us write it down freshly. The coordinate of Q is cos y, comma minus sine y, here from this diagram. Now let us join point A and Q, where Q is the point that we have got by subtending one angle y in clockwise direction, and whose coordinates become cos y, comma minus sine y. Now our next task is to find out the length AQ. So from the distance formula, we are getting AQ as x2 minus x1 whole square plus y2 minus y1 whole square. By applying that formula, we are getting cos x minus cos y whole square plus sin x minus sin y whole square. Thus, expanding this, we get AQ square is equals to cos x minus cos y whole square plus sin x, this minus minus becomes plus, plus sin y whole square. Further expanding, we get cos square x minus 2 cos x cos y plus cos square y, that is a minus b whole square formula plus a plus b whole square formula. After applying that, we are getting sin square x plus 2 sin x sin y plus sin square y. Now here one thing to observe, that cos square x and here we have sin square x. Again, that basic identity of trigonometry, cos square x plus sin square x will become 1, Similarly, cos square y plus sin square y, these two also will become 1. Thus we get 1 plus 1, 1 for this cos square x sin square x, and this one for cos square y and sin square y, minus 2 cos x cos y plus 2 sin x sin y. Therefore, so finally we are getting ab square is equals to 2 minus 2 cos x cos y plus 2 sin x sin y. Let us write down the previous result 2, that is length of BP, that is BP square is equals to 2 minus 2 times cos of x plus y. Now the vital part of this proof is these two triangles, triangle BOP, here this BOP, and triangle AOQ. If we observe, then in triangle BOP and in triangle AOQ, we can see that OB is equals to AO, because it is a unit circle and both AO and OB are the radius of the circle. Similarly, OP is equals to OQ. So we can observe OB is equals to OA, OP is equals to OQ. The reason is same. Both are the radius of the circle, of the same circle. Now, one more important thing here. We have to observe angle BOP. We can see this angle BOP is angle Y plus angle AOP. Angle Y here plus this smaller angle, angle AOP, and angle AOQ, that is equals to this angle Y. No doubt it is minus y because of its direction, but the magnitude will remain same. So let us write down the magnitude. So it is y plus, and in case of angle AOQ also, y plus this smaller angle AOP. So from these two statements, can we write angle BOP is equals to angle AOQ. Therefore, OB is equals to AO, OB is equals to AO, OP is equals to OQ, and this total angle is equals to this total angle. Therefore, triangle BOP is congruent to triangle AOQ by side criterion. Hence, the length BP and the length AQ, they will be equal by CPCT. So we can write length BP is equals to length AQ by CPCT, property of congruent triangles. Therefore, we can also write, since AQ is equals to BP, that implies AQ square will also become equals to BP square, and the values of both AQ square and BP square we have already calculated. If you remember, we got this AQ square by applying distance formula from these two given coordinates, cos x minus cos y whole square and sin x plus sin y whole square, and after expanding we have got this value, and BP square we have calculated by applying the distance formula in points B and P, that is 1 minus cos of x plus y whole square and 0 minus sin of x plus y whole square, and previously we have derived this result. So since AQ square equals to BP square, therefore 2 times cos of cos x xy and plus 2 times sin x sin y, and here 2 minus of this value, that basically we are equating AQ square and BP square. So from this equation here in LHS and RHS we can cancel out 2, and thus we will left with this value minus 2 cos x cos y plus 2 sin x sin y, and here in RHS minus of 2 times cos of x plus y. Finally, if we take minus 2 common here, then we shall left with cos x cos y minus sin x sin y, and here minus 2 times cos of x plus y. Thus if we cancel minus 2 on both the sides, then we shall left with the result cos x cos y minus sin x sin y is equals to cos of x plus y. So for sin square x plus y, we can now write 1 minus cos of x plus y whole square, because we know sin square theta plus cos square theta is equals to 1. By using that identity, we can write down this statement, and if you further expand it, then we shall left with sin of x plus y is equals to sin x cos y plus cos x sin y. I want you people to try it with. So that's all in this video. Thank you for watching.